Hi, today it's all about diffusion and how to evaluate the rate of diffusion. Um, Diffusion is nothing but um, molecules which are moving from a higher concentration to a lower concentration without the addition of any external energy. Uh, for that, what we're going to do is in the dialysis tubing, we're simply going to tie up one end of the dialysis tubing. This has to be have soaked in water, and you're going to put in 2 mils of the iodine solution in over here. You're going to tie it up on the top. You're going to tie it up tight again. Make sure that there is no kind of leakage happening. And once it is tied, we're going to dunk it inside a beaker of starch. Uh, for this, you're going to make sure that the beaker is filled with starch up to 100 mils. This experiment is based on time. So the moment you dunk it in, you start your stopwatch or your cell phone and wait for 5 minutes. It's more of a visual experiment. You will see diffusion happening from the iodine over here, which is in here, into the starch. And the moment iodine hits starch, it is going to turn blue. At 5 minutes, you're going to be asked to take off or pull out the iodine Lugol's solution, the dialysis tubing, and you're going to keep it on the table. Uh, Once that is there, you give it a stir, you get a blue color. Then what we're going to do is actually use our spectrophotometer. It is a visible spectrophotometer, and it follows the principles of Beer-Lambert's law. In Beer-Lambert, its absorbance is directly proportional to concentration. So you need to understand the equipment prior to using the equipment, and hence this video. So what we are going to do is, prior to even starting off this experiment, we need to have open the cell compartment. The cell compartment, you will see 4 cuvette holders over there, and once we occupy the first 2 slots. That means facing you, the first 2 slots. Always try to keep this lid of the spectrophotometer shut as quickly as possible, because there is a light sensitive detector. In this spectrophotometer, we have a source of light. We have a grating which splits the light into, it's visible from 400 to 800 nanometers. We select the specific wavelength what we need. It is already done for you in your case. And then the sample is where that particular wavelength strikes the sample. If it was water, 100% is transmitted, 0% is absorbed. But as the color starts increasing or getting darker inside your sample, the amount of transmission is much lesser, the absorbance is much more. So when it starts getting darker, it means just that it's basically having a increased concentration. Hence, absorbance directly proportional to concentration. So once we have the 2 cuvettes, or the cell holders, these are called as cuvettes, you want to put it inside such that the transparent portion is facing the beam of light. You want to make sure that it is showing you as 0, 0, 0. If not, you want to press the 0 button. So once you press the 0 button, it linears across, and all the slots tend to show 0. At this point of time, you want to make sure that the 2 cells are matching. And most of the times we've already matched the cells for you, so you should not have to worry. So I'm going to take off the 2 cells. They are matched, both are showing 0, 0, 0, This was just water. So I'm going to dunk it down the sink. So I know that the cells are matched, so we don't have to worry much about it. I'm going to fill up this cubit with starch, and like how I often give this example, like how we actually tear in a balance. You're going to basically span your equipment by now pressing it 0, because you did get an absorbance. As you can see that this color may be slightly turbid. It's very low concentration of starch. So I see that I've got 0. I'm going to take off the cuvette, shut the lid, pour it back into my sample beaker. In this experiment, like I said, I'm going to first tie up one end. You want to make sure this is really tight. How you open a vegetable bag in the market, that's how you twiddle with it a little bit here and there, and it opens up, and you're going to take in exactly 2 mils of the solution. It's iodine solution. Try to push it in deep. It sometimes gives a little trouble, but once you put in your 2 mils over there, you should be good. And tie up the other end over here. So we can expect that diffusion is going to happen through the semi-permeable membrane from the dialysis tubing into the starch. So we're going to see that shortly. And I'm going to dunk it in, and you're going to see the time. It's 11:49, and we don't stir it once we've put it in, and we shall wait for 5 minutes for the diffusion to happen. If you take different concentrations of the Lugols, you will see that the diffusion is different for different concentrations. And for your experiment, you're going to do it with another concentration as well. You can see that in 5 minutes time, quite a bit has got diffused. You're going to take this sample, and you want to measure the absorbance, which we had zeroed the equipment. If you've noticed, just like how you tear in a balance, once you take off the weighing paper, there will come a negative value. That's the negative value what we see. And I'm going to just fill up the cuvette. There is a triangle on the cell or the cuvette, and you want to make sure that it is just up to that mark. The transparent side has to be facing the pathway of the equipment. I'm just going to put it in the cell compartment, the first compartment as you see. If you put it in the second one, we would have to pull it out one shot. You can take up to 4 readings. But in this case, we're just taking one. I'm going to put it in the first one, and I will get a measurement value. The absorbance shows to be 0.102. So we have the concentration, we have the absorbance value, we know the time. So we're going to put the absorbance value on the y-axis, and you're going to have the time 0 to 5 minutes, plot a single point curve, and you will get a particular slope to that curve. The same thing you have to repeat with the different concentrations of the Lugols, and then you can see the slopes of the curve changing. Once you can see that, you can then determine the rate of diffusion. So I hope you have at least got yourself familiarized with this equipment. Thank you for watching this video.